Hello and welcome to our Northcoders final project, worldARt. We are a group of 4 which includes Alistair, Sang, Naomi Todd, Jordan Reynolds and myself, Sam Rowland. We worked remotely on this worldART project from planning to completion in just over 2 weeks. worldARt is an augmented reality application which allows the user to search through thousands of pieces of art across the world, pick and choose their favourite pieces and save onto their personal profile, then using the augmented reality to put these pictures up on their walls in their house to create a personal virtual art gallery. When we were coming up with ideas for the project, we wanted to think reactively to the current situation which is happening. We felt that we wanted to create something which could be informative, but as well being entertaining and interesting whilst being on a lockdown. We aimed to build something which gathered information about various cultures across the world, which is how we agreed upon the idea for worldART. The average user for worldART is an art lover, someone who enjoys visiting art galleries and museums. It could also be anyone interested in technology such as augmented reality. And it's also for anyone who just wants a fun distraction in their lives in this boring time. We as a group agreed that we all had a great interest in the capabilities of augmented reality, as it being the focus of our project, as well as exploring new technologies which were not part of the Northcoders curriculum. We also tried to implement new technologies in almost every aspect of this project.
So first we're going to sign up as a new user and create an account. And then on sign up, we're greeted by a tutorial screen on first sign in explaining how the AR functionality works. Home page is a country list where you can browse all the art available from the Met Museum API. Go for Belgium. And that then loads an image grid of the art available from that country. If you see a piece of art that you like the look of, you can click on it for more information. And then if we click Save to Gallery, that art will now be available on the Profile tab. We'll now sign in as an existing user so that we have some pre-saved art to play with. We'll go to the AR screen and flip the orientation so we can see the wall where we want to place the art. If we click the gallery icon, we can access the saved art and click an image to render it in the Viro scene. You can click on an image and drag it to your preferred location, and then you get a menu to change the size of the image. You can then click the gallery again to add multiple items of art to the wall, and again move them around with the menu options. If you add an image but then change your mind, you can also delete the art here. If you click the camera icon, it'll take a screenshot of the art on the wall and save to your camera roll and your profile. As you can see, you can move the camera around in the real world and see the images fixed to the wall pane. Now if we go to our Profile tab, we can see the screenshot is saved along with earlier photos we've taken in the app. Now we'll have a look at our tech stack.
Initially, we were going to use Express for our backend. When we were forced to simplify the front end, which Naomi will talk about more later, we decided to increase the complexity of our backend. So as a team, we decided to use Amazon Web Services, AWS. We chose AWS, firstly, because the services that it offers were ideal for what we wanted to achieve with the backend. But secondly, and more importantly, it was a brand new piece of technology. And throughout the project, we strived to learn as much new technology as possible. And AWS is something that we were all really interested in learning about anyway. For our database, we chose to use DynamoDB, a NoSQL database from AWS. We chose DynamoDB because the data structure that it uses lends itself well to the data that we wanted to store, as we're only storing the users and their related art. We created a RESTful API using API Gateway, which have multiple endpoints for HTTP requests, such as posting or getting user data. Using API Gateway alongside DynamoDB meant that we were able to follow an MVC architecture pattern, which is something that we're all familiar with. So it allowed us to easily understand the relationship and flow between the services that we were using. We connected the database to the API using Lambda functions. We chose Lambda functions because they're easily integrated with DynamoDB, as well as having their own integrated testing, which meant that we could test the database and the requests that are made to it to see if they were functioning properly before implementing them into the front end. For the images that are taken in the AR screen, we decided to use an S3 bucket to store them. We chose S3 because it's simple to use and ideal for storing and retrieving large sets of data, such as images. But also, it's easily integrated into other Amazon Web Services, which in our case is just the API Gateway. We didn't need to use a Lambda function for the uploading of images to S3 because we used a React Native package, which converted the image to a base64 string and uploaded the image directly. So how would this app work from a technical standpoint? The user would log in or sign up. When the user signs up, a request is made to the API, which triggers a Lambda function and then creates a new user in the database. Then when the user's logged in and they decide they want to save a piece of art to their gallery, a request is made to the API, another Lambda function is triggered, and the user table is updated. And then when the user goes to their profile and wants to view their gallery, a request is again made to the API, another Lambda function, and the art is retrieved from the database and ready to be rendered on the page. When the user's on the AR screen and they take a screenshot, the image is uploaded to the S3 bucket. And then when the user again goes to the profile, but this time clicks on the screenshot, a request is made to the API and retrieves the screenshots ready to be rendered on the page. We will now talk about our front-end technologies that we use for our project.
The predominant technologies we used in our front end were Viromedia's React and React Native. Augmented reality was a main focus for us as a group from the start, and we were all inspired by various apps and games that we've enjoyed in the past, such as Pokemon Go and the IKEA AR app. React is a branch of Viromedia's open source platform for augmented reality and virtual reality, which works specifically within React Native applications. We felt that there were various benefits of using this technology. The documentation was clear and easy to pick up, and the Viro testbed app was quick to set up and gave us a lot of efficiency and instant feedback when we were building and testing the app. We also wanted to build something that could be used for Android and iOS. Because of the choice of using Viro React, React Native had to be the choice for our front-end application. We're excited to use React Native, as we'd used React in the past in our previous web applications during the course, but we all wanted to explore the capabilities of using React on a mobile. Throughout the project, React Native was a solid framework for us to build our application. We wanted to make sure that the navigation through the app for the user was seamless and simple, where we use React Navigation Library to achieve this, although we did come across an issue of having to use a dated version of it because of Viro React. Our goal was to gather information from the Met Museum's open source API using Axios to then organize and show various art pieces to the user, then allowing the user to access more information such as the artist's name, when it was created, and more information about the pieces. Inside the AR scene, we wanted to implement a functionality for the user, including resizing the image when it's rendered, screenshot functionality which is saved to the backend and the user profile, and the ability to choose and delete any pieces if the user did not like it.
Throughout our project, we made use of Agile Practices in order to keep things more fluid and flexible when creating our project. Before we started coding our project, we first took the time to use wireframe to plan out what our application will look like so that we all have a clear vision and goal to work towards. We also used this time to create a component tree so that we know where our components will sit and also how they interact with each other in the front end. We also use a Trello board in order to keep track of how our app is progressing and what we have done and what we still need to do in order to create our MVP, in order to achieve our MVP. We have 2 daily stand-up in order to keep everyone in the team informed and on track with our project. We use this time to discuss what we have done and also any problems that we have encountered so that we can all offer up potential solutions through the practice of mod programming. And now, onto the problems that we have faced throughout our project.
Viro React currently only fully supports React Native up to version 59.9, and this caused us some issues when trying to integrate third-party packages. Although some did work with earlier versions of React, dependencies were often incompatible and we were unable to use components within the Viro Media testbed. This meant customizing elements of the app was more difficult and took more time. Workarounds we used included an older version of React Navigation, as their documentation is comprehensive and still available online, and some local images for icons. The main issue we had with integrating other modules into our app was using Google Maps. Our original plans was to have a country screen as an interactive map where the user would click on a country and see art from that location. Early in the project, we spiked the tech required to build this element but were unable to integrate with the Viro test app. We explored the use of other developer tools such as Xcode to build and test the integrated app, but the older React Native version and hardware capabilities meant this just wasn't a viable option. The issue was flagged as urgent during one of our stand-ups, and we took the opportunity to review our MVP and made the decision to simplify the country selection for this iteration. For AWS, the setup was slow and documentation was complex. When someone got stuck, the fluid nature of our roles allowed each member to help out or even swap roles if a team member was particularly stuck. We screen shared and worked through issues as a team. Unreliable internet connection and distractions that come with working from home meant we sometimes had to be flexible with stand-up times and working hours, but we kept the rest of the team informed and used mobile data where possible. Our Agile Practices ensured that we kept communicating. Next, we'll look at what we could do differently or additional features we would look to implement.
As mentioned previously, the outdated version of Viro React has caused a lot of compatibility issues. And if we were to restart our project again, we would have looked at a different AR platform to build our app so that we can have a more updated version of React to work with in order to incorporate additional features such as AWS Cognito. If we had more time, we would definitely look at styling our app a lot more, but due to time constraint and again the outdated version of Viro React, we couldn't make use of different libraries such as React Native Icon. An additional functionality that we would have liked to implement in the future would be a social and gaming element in order to appeal to a wider audience. We would also like to have added the feature of adding your own personal art into our gallery so that we can render it in AR. We'd like to thank you and hope that you have enjoyed listening to our presentation. If you have any questions about our project, please ask in the comment section below and we will do our best to answer them. Thanks.